Okay, so we are going to cover on Chapter 8, Benefit and Cost Analysis. What do you think we are going to learn in this chapter? What first comes to your mind when we introduce this topic? Anyone? Nothing comes to your mind. Yes, anyone? Just want to make sure I'm not talking to myself. Hello? Are you guys there? Interest rate. Okay, of course, interest rate is, even the first chapter, you can say interest rate. So the answer is apply for all the chapters, right? But specifically when we say benefit cost analysis.
Profit or non-profit?
Profit or no profit. Okay. Basically that what we are covering when we're discussing about this economy, right? Okay, let's go. By the way, let me introduce myself. My name is Al-Amin bin Muhammad Sultan. So I'm a senior lecturer in Faculty of Manufacturing Engineering. I'm an alumni of UTEM. I did my diploma here in UTEM and also my degree in UTEM. I completed my master in industrial engineering from UTM, University of Technology Malaysia. And I also completed my PhD from the University of Manchester in sustainable manufacturing. So now I'm as a senior lecturer in Faculty of Manufacturing Engineering, and then I also am the principal in the student residence here in UTEM. So some of you may know me, as you can see some familiar names here, but hopefully for those who are the first time, then hopefully it's going to be a great thing that we have a chance to be in the session. Okay, so those are the learning outcomes of this subject. So this is the list that what you should know at the end of the session. Basically, we are going to see what's the difference in between public and also the private sector projects. So we have projects, right? So it's been developed, it's been organized by both public and also private. So we're going to see briefly what are the differences between them. And then we are going to introduce the BC ratio. Basically, we are going to use BC ratio here for calculating or assessing the single project. Okay. By the way, while doing this lecture, if you have anything, please speak, as I rarely can see the chat box message. Okay, so let's continue. So we use BC ratio here for single project, for assessing single project. So for more than one alternatives, so for basically two alternatives, there is a BC method. Okay, here is BC ratio, here is BC method. And we also have cases for multiple alternatives, means that more than two alternatives to be compared. Okay, so we are going to use the BC method as well, but they may have some differences. And I think the last part is going to be the CEA, which is the cost-effective analysis, where we're going to use this usually to evaluate the service sector projects. And finally, we're going to conclude the session basically on the discussion on ethical compromises that may enter public sector project. Okay. So while this lecture, hopefully if you have any question, then you can just interrupt so we can have a discussion. And I believe the former students of UTEM, you may have some points as well, although this is a new chapters that have not been covered before. So let's start the differences between public and private projects. So the characteristics and also the explanation have been listed here. Basically, you can just read by yourself, right? So let's go quickly. So size of the investment for the public project usually is large amount. Okay, usually is large amount. And for the private, they're covering various range of the investment from small, medium to large. Okay, and when talk about the public project, the lifetime is longer. Okay, so it's 30 to 50 year plus, while it is said that for private project it's going to be shorter, 2 to 25 years. So basically what we are talking here is public is usually who usually initiate the public project. Anyone? Who usually initiate the public project?
Is ministry?
Ministry, exactly, Aswan, right? Thank you. Thank you very much. So ministry basically is by the government bodies, right? To the betterment of the people, for the society. So they not really merely focusing on the profit. There's no profit. It's a public project. So what's the example of public project, guys? We are Malaysian citizens, right? So what are the public project that benefits us? Maybe till today.
Bus stop.
Bus stop, okay, bus stop, you know. What else?
Public toilet.
Public toilet. But you need to pay, right, nowadays? But that's for, I don't know, that's for, I don't know, for daily operation or cleaning things, I don't know, that's fine. And basically the private projects is profit driven. So they are not doing it for charity, right? But the government, they are doing it for, basically they are not doing it for free. It's actually from the taxpayers' money as well. So we can see how it's related. Non-profit because the funding is from the taxes, right? The fees, the bonds, etc. Basically we pay the tax. And government also have their income, and then they return it back in terms of project that benefits students. I mean, the citizens. While the funding for the private is going to be from the loans, bonds, stocks, and interest rate is lower, and for the private sector is higher. Even if you are government staff, you have the privilege to many things, right? So that's also counted here, like your housing loans maybe is going to be lower, right, compared to the conventional banks. Depends on the current Malaysian or our economics. So selection criteria, they may have multiple criteria. So when they want to choose a project, either to accept, to do, to execute or not, so they may have different criteria, or they have things, you know, selection criteria, maybe based on necessity, demand, how many people, but usually I can strongly say politically influence on this. You know, if it's going to have election, then we may see many projects being announced. So one of the criteria is politics. You know, you can't deny that, right? And for private, they are going to focus on ROR. What is this? What is ROR, Ramli or Rahim? Come on, guys. Do you know this? Sorry, Anis, I couldn't catch your words.
Rate of return.
Rate of return. Thank you. So I believe this been covered, been explained, been introduced, and you also have some calculation related to this ROR on previous chapter by Mr. Akramin. So basically, it's on the rate of return. So if it's high return, high profit, so that's going to be the decision made based on that. Yes, this is what I have spelled out just now. Usually it's politically inclined, and this one is merely on the correct. But sometimes this politics can also disturb this private thing, but that's other stories. Okay, so this is basically, we want to understand the public and also private projects. And here they are explaining about, you know, types of contracts. Okay, so we have contractors who does not share the project risk, so they just do, they don't count any risk in regards on the project. and usually involve the lump sum payment. You need to pay and they doesn't care after they deal, after they transfer to you. So they are not going to hold any risk of the project. Where the cost is reimbursable, so they're going to be paid after that. And we have another type of contract, which is the contractor shares the project risk. What is the example? Is the public. Usually we use this term, public-private partnerships, PPP. Okay, so public and also the private sectors, they are going to join together, collaborate together in developing certain projects. Okay, so in design, so they in charge from design to build the projects. Okay, so the contractor will be responsible from design stage to operation stage. Okay, and there is a project which involve not only until the operation, but also maintenance and also the finance. So we have one project in U10 till, from my understanding, we have one PPP project, which is student residential. We have 5 blocks of Satria Residential College, consisted of 5 blocks, can accommodate about 5,000 students in one time. So that one, the example of the PPP, where private and also the government collaborate to build that project. So it's like we are paying monthly the like a rent, but after 25 years, you know, the contract after 25 years, then it's become UTEMS. So now it's still under concession. Even the maintenance are being take care of them. Okay, so now we are going to see these BC relations. So what we should do, okay, we need to identify. You're going to be given a scenario, right? I believe in whatever chapters in regards to this economy, you're going to be given a scenario. They're going to give you problem. They're going to give you some information on cash flow, cash in, cash out, interest rate, and period, and some other related information. So we call it scenario, right? So you also going to be the scenario, the same. So in this case, we need to identify the benefit. You need to identify the disbenefit, or sometimes in a form of cost. Okay, so that's what being signaled here by B is for benefit, disbenefit, cost. Okay, so what is benefit? Benefit is the advantages from executing that project, that particular project. So they are going to have some advantages to the public, right, to the people. So that we consider as benefit. While this benefit, D, is the disadvantages. By handling that, by implementing that project, is going to have some disadvantages to the public. So that's going to be counted as disbenefit. And of course, we can't run away from the cost. So what are the costs that involve in that scenario or in that project? Usually expenditures by the government. Okay, so I hope you get the, we're going to see the example, of course, but hopefully you got the point here on B, D, and also C. Okay, and there is a note here, if we have savings to the government, okay, if the scenario says, and then we identify there is a saving, we have excess money from the project, so we are going to subtract from the cost. So that's the note here. Okay, so by understanding or by the ability to extract the information based on B, D, and C, so we are going to use the formula here. Okay, so we have conventional BC ratio. Usually we are going to calculate based on B minus D, which is benefit. We are going to minus with the disbenefit and then divided by the cost. So this is the conventional BC ratio method. And we also have modified where we have slightly different, which is B minus D, which is benefit minus disbenefit, and we also minus the cost and then divided with the initial investment. And we have another, which is profitability index. What is this profitability index? The net cash flow. So we are going to calculate, we're going to get the net cash flow value, where we are going to divide it by the initial investment. Okay, so this is basically the theory part, right? The fundamental of understanding this cash flow classification in regards to BC. So we have to bear in mind all terms must be expressed in same units. Okay, so if you are using PW, then you have to be consistent with PW to at the end. So we're not going to mix it up because it's going to give wrong reason. Even you can't compare. P value gives something for case 1P and then case 2A, so you can't compare, right? So you need to be consistent, use the same units. And we are not going to use minus for the cost, right? Let's say cost is 500,000. So we are not going to write, when you're doing mathematical operation, we are not going to put minus sign. Okay, so I hope it is clear. Okay, so next we are going to see how we are going to get extract the information from the scenario, right? But how we are going to decide the benefit and cost analysis, that's what we are going to see in the next slide. Okay, so for benefit cost analysis, so we have the BC ratio. So if it's equal or greater than 1, we say that project is economically justified at a discount rate applied. Right? Means that we're going to accept. So if the BC ratio is smaller than 1, so what we say is the project is not economically acceptable. So basically from the calculation, using this formula for BC ratio, if you got 1 or more than 1, so we are going to accept that because it's economically justified. If it's lower than 1, we are going to reject. Basically say it's not economically acceptable. And another is profitability index. Basically going to have the same procedures. So if it's more or equal to 1, the project is economically justified. And if it's lower than 1, it's not economically acceptable. So now for the BC analysis for single project, okay, so we can use conventional BC ratio. B, what is B just now? What is B and D? Benefit and disbenefit. Right? The difference between benefit and disbenefit, I'm going to divide it by the C. So more than 1, we are going to accept. 1 or more than 1, we're going to accept, otherwise reject. And the PI, profitability index, is going to, we're going to calculate the net cash flow diagram, net cash flow. So PW, and then divided by the initial investment of PW. So present, the current value, right? The present worth. So if you got the same thing, if PI greater than 1 or equal to 1, we're going to accept the project. Okay, so this is, sorry, just come out just now. So the same thing for the modified BC ratio, where here we include the maintenance and operation, right? Maintenance and operation cost. Let's go to the example. If not, then it's difficult for us to understand, right? So you can read this. The flood control project will have a first cost of 1.4 million with an annual maintenance cost of 40,000 and 10 years life. Reduced flood damage is expected to amount to 175K per year. Lost income to farmers is estimated to be 25,000 per year. And the interest rate is 6. Should be the project be undertaken. So what should we do? First, guys. So this is the scenario being given to you. Yes.
Identify the benefit, disbenefit, and also cost, and also the maintenance cost.
Exactly, exactly. That's one. Thank you. So we are going to identify the B, C, and D. But before that, we need to also to have some idea which approach that we are going to use. Is it PW, AW, or what? FW? Which one is the best? So you can use any, right? No problem. But which is best to be used? By reading the scenario given.
FW
FW. Why FW? First one?
is what the end words that we can achieve.
And words. Okay. Thank you. Thank you very much. Anyone else that have different opinion, different suggestion? You can see Aina there. Hi, Aina. Are you there? Hello, Aina? Okay, she's not answering. Hi, Lokman, are you there?
Yes, Doctor.
Yes, Lokman. So your friend Swan said FW. How about you? If you are calculating this. No idea. Yes, Lokman. What are you doing? Yes. Okay.
Sorry.
Sorry?
Maybe PW, present work.
Present worth. Okay. Why present worth? So
Because
Lokman
they
said,
give no, Doctor. No, because the question they give present work. First cost is the present work, and the maintenance is the annual.
okay.
N
Okay.
equal to 10-year life.
Okay, you're almost there. So PW.
No. Sorry, Doctor. So I think FW.
FW. Okay, so you agree with Aswan. Why FW suddenly?
The project.
Yes.
Okay.
You said PW and then now you agree with Aswan to FW because you want to know the future's value. Is it?
Yes, because they already give the present worth already.
Okay. Thank you, Roman. So class, basically you can use whatever it is. You can use FW, PW, or sorry, you can use FW, PW, or AW. Okay, but it's just us. We want to choose the approach that not going to take us time to convert this from that from this. So why we are going to, like, when we read the question, we try to find it out. So you have the first cost of 1.4 million is P, right? And then they say they give the annual maintenance cost is 40,000. So this is A. Reduced flood damage is expected to amount 175,000 per year. So what is this? Yeah, exactly. Lost income to farmers is estimated to be 25,000 per year. What is this?
Yep, also A.
Okay, so now which that we should use?
AW is easy.
AW. No, I mean it's still okay to use FW and PW. But what you're going to convert, you're going to do the factorial, we call it, to A. Three information here, you need to change it to FW or PW, right? If you use AW, you just use this value and you just need to change PW to A. The conversion, only one conversion need to be done. Instead of choosing these three, you need to change it to P, so you need to do three activities. But it's not wrong, just okay. Did you get what I'm trying to explain here, guys? Did you understand?
Yeah, okay, Doctor.
Okay.
Yes.
Yes. I'm going to wait for the response, because if not, I'm not sure. Okay. So first is express all values in AW terms and find BC ratio. So now BC ratio. What is B? Benefit.
Reduce flood damage, 175,000 per year.
Yes, exactly. So this is the benefit, right? What's the benefit to the public, right? So reduce the flood damage. So it's 175. Okay. So B is 175. How about D? This benefit.
A lost income to farmers.
Yeah, exactly. This one. So this is this benefit, right? It's lost. They lost their income. Okay, it's estimated to be 25,000 per year due to this project. Okay. So we have B and D. So how about C? What is C? Cost. Right. So what are the costs that involved? So we have here 1.4 million. What is this? This is P, right? Yes or no?
Yep. Yes, Doctor.
Okay,
Yep.
so we are using A, so we need to do some conversion, right? So how to do that? 1.5 million, then you want to find A given P. So is it going to be A over P or P over A?
A over B.
A over P, exactly. So 1.4, okay, 1.4 million. So you need to convert it, because this is P. Now we want to A, because we have choose the unit here is A, here is A, so C also should be A. So it's going to be A. You want to find A given P. So what's the interest rate? 6% given, right? 6%. And then N, what's the N? 10 years.
Yes.
Okay. So by doing this, we have convert this cost, the first cost, from P to A. Okay. Is this the only cost that involved in this calculation, in this scenario?
No, they have maintenance cost, Doctor.
Yes. Where is it? Yes, here. So it's in A, right? So we need to add this with 40K. So by doing this, okay, so we are going to get the C. Okay. So we got something like this. You can check the calculation later. Okay. So now we have all the information that we want. So we are going to do the BC, basically the BC analysis. So what we are going to do? B minus
B over C.
over C. So you got this. You should got this answer. 175 and 25,000 minus, and then you divide by the total cost. So we got 0.65. So this is smaller than 1. So in this scenario, we're not going to accept the project, right? So basically, the idea behind this BC ratio, if you got one or more than one, means that you are making means that the benefits are higher than the cost, and also these benefits. So that's the things. So I hope you got this. So here we have question which you can try. I hope you can try. Can you try now? I give the answer here. Okay, can you try and share the answer? So I want all of you to try. Just simple, right? Just easy. So what we need to do first, just read the scenario. The cost of grading and spreading gravel on a short rural road is expected to be 300,000. So what is this 300,000? It's a cost, right? It's cost. So you have the cost, 300,000. Please try. I'm not going to do the solution for this. The road will have to be maintained at cost of 25,000 per year. So they have maintenance cost 25,000 per year. What else? Even though the new road is not very smooth, it allows access to an area that previously could only be reached with off-road vehicles. So they give some advantages to the people. So the improved accessibility has led to 150% increases in the property value along the road. So if the previous market value of a property was 900,000, okay, calculate the BC ratio using an interest rate of 6% per year for N is 20. You want to try? Anyone? Can you try by yourself? So we got C, basically the cost. Are you doing? Are you trying, guys? Anyone want to share how to do this? Present market value, what's that? Let me check the, where is the chat? We have struggle with the chat things. Okay. Okay, you're typing here. Okay, let me check. Okay, so Loga Varadan and Chandra are replying. So 450,000. What's that? 450,000. Is it the least benefit? Okay, so minus 900,000. Okay. So your friends have shared here, so they get 450K. So what is this? Benefit or this benefit? What is that? Benefit, right? benefit. Yes, exactly. So basically, we know the cost is 300K. We have maintenance cost 25,000 per year. So this is A, right? So this is 450, the benefit. From which case we read here, it said that improve the accessibility that has led to an increase of 150% of the property value. So previously it's 900,000. So if we calculate that the increment is 450. So this is going to be the benefit. Yes, you are right. So now what we need to do is we need to get the calculation. Okay. So in this case, since this is in present worth, 300, is it in present worth? I guess so. So we have only A here. So in this case, we may want to use PW. Right? Because this is P, this is P. So we have A, so we just change it to P. So we can just do the formulation. Or you can just do A, but you need to convert this to A and this to A. Okay. So 400. So we have benefit 450K. And we're going to divide with how to calculate it. How about the cost? So 300,000 plus what? So we have another cost which is 25,000. Can we just add? No, because this is in A, right? So we want to find P's given A. What is I? 6. How about N? 20. Okay. So we need to do this. So it's not PW, it's a BC ratio using PW. So I believe if you solve this, you're going to get the answer. Hopefully, if not, then I don't know. You check. You check and let me know. Okay.
Doctor means this there is no this benefit here, right?
Sorry.
There is no this benefit.
Yes. In this scenario, there's no this benefit. So basically, we just assume this D is 0. So have no meaning by putting 0. So we just ignore because it's not been given. Yes. But if they give this benefit, then we need to include into the calculation. Thank you for asking this now. So I hope this is clear. Basically, it's very straightforward. We just need to extract the information of B, C, and D, and then we do the calculation. So here we got 0.77. If 0.77, we are so this project is economically it's not acceptable. It's not justified. Okay. And we have question 2. So I don't want to take more time. I believe you can do this, and I suggest you to do this by your own. And the answer is here. You can always refer to the answer. Okay. Make sure you know how to get this to calculate this. Okay. Can we just continue?
Yes.
Okay. So now I'm introducing the terms of defender, challenger, and do nothings. Those are the alternatives for us to compare. Okay. So when we have more than 2 or more alternatives, so we are going to have a defender. What is defender? So this is the terms. Okay, this is the terms. This is the in-place system. So defender is if you have a machine and you are thinking of changing a new machine, right? So somehow we say that in place system or currently selected alternative is the defender. Okay. Challenger is alternative challenging the defender, means that this is the new option that we bring in inside in our comparison. So that's challenger, and we also always have do nothing, so no need to do anything, right? So this we call status quo of the system. So defender and do nothing option have sometimes have some similarities, but usually we're going to say do nothing is we even don't analyze the defender, and we're not going to do anything. So general approach for incremental BC analysis, we are going to choose the lower total cost alternatives is first compared to do nothing. Okay, so what we are going to do, what we are going to do, the lower cost alternative. So we are going to choose the lower cost of the scenario. We are going to compare with do nothing. Okay, if BC for the lower cost alternative is lower than 1, then do not option is compared to BC ratio of the higher cost. Means that we need to choose the lower compared with do nothing. If it's lower than 1, means that do nothing win, right? Because do nothing is from the analysis lower than 1. So do nothing, then we are going to compare with other alternatives. So if both alternatives lose out to do nothing option, so do nothing prevails unless overriding needs required. Means that we need to see if do nothing get lower than 1. We're going to see the example for clearer understanding. So the procedure, we are going to use incremental BC, 2 or more alternatives. And this is similar to ROR analysis for multiple analysis alternatives. So if I'm not mistaken, this should be covered in your previous chapter. Okay. So what you're going to do, there's 7 steps here. The first is determine the equivalent total cost for each alternatives. Okay, equivalent total cost. So we need to compare with the same approach. If it's PW, then we need to compare all PWs. And then we are going to order the alternatives by increasing total cost. So we order them. And then we are going to identify the B and D for each alternatives. Okay, so we need to calculate B and D. If it's given, means that B and D is given. So we need to go to step 5. If not, we need to calculate, right? So we need to calculate BC for each alternative and eliminate all BC with a value of lower than 1. And then we're going to determine the incremental cost and benefits for first 2 alternatives. Of course, we are going to calculate the BC. Higher than 1 means that it becomes defender. So we are going to repeat these steps until we only have 1 alternative remains. So that's we call it the winner that's going to be chosen. Okay, let's go to the example. Okay, so here is the example of the application on incremental BC analysis. So compared to alternatives, they give I is 10% and BC ratio as given. Okay. This is the first cost. First cost. This is maintenance cost. Okay. This is benefits. This is this benefit, and they give you life. Okay. So what we should do first? So we need to calculate the equivalent total cost. If you still remember here, this is the first thing that we need to do. Determine the equivalent. We want to compare them. So in this case, this is per year, this is per year, this is per year. So which approach that might be efficient for us to use?
AW.
Sorry?
AW.
AW. Okay, thank you. So AW. Is that wrong if you use P? No. It's not wrong, but it's just we want to reduce the, reduce the steps that we need to do, the calculation. So we are going to use AW. Okay. So we're going to calculate the equivalent total cost here. So AW for X and AW for Y. So I believe you understand how to calculate this. Okay. So AW 3320, because this is in P, first cost is present value. So P is given, so we find A with the factorial factors here, and then plus with 45,000. Okay, these two are the costs that we are going to calculate. So plus 45,000, and then for AWY is this, you understand, right? Okay, fine. So we got 97,080 and 98,428. So we are going to order them. Okay, lowest from the increased order. Okay, so order of analysis, we are going to analyze X first, then Y. So I want to ask you a question, why we are doing X first? Anyone? Hello?
Maybe 10 years.
Sorry, maybe 10 years. Okay. Thank you, Lokman, for the answer. So Lokman said maybe because it's 10 years, shortest period, so we start with the shortest period first. Okay. Thank you for the answer. But we have different criteria here. Okay, anyone want to try? Aina, are you back? No. Yes, Mulyati, are you there? Yes. Yes. Do you know why we are analyzing X first? Here, the first thing is we analyze the equivalent total cost. So we know that the value is this. And then we are going to choose X first. Why? Yes, Mulyati, any suggestion? Loga said lower cost. Okay, that's fine. We just go. Okay, basically it is the steps. We need to choose the lower cost first, as Loga said just now. Okay, go back here. This is the steps, right? We determine the equivalent total cost. We done this, and then order alternative by increasing total cost. So we order it from lower to the higher. So why we choose X just now? So what's next? You're going to identify B and D, and then calculate BC, and do the incremental cost benefit. Okay. So now we're going to analyze X versus do nothing option. Okay. So we're going to do the BC analysis. So B, D over C. Right. So X is this one. So what is the B? This. What is D? Is this. Right? We're analyzing it. So it's already per year. A, right? So we can just directly minus 110,000 minus 20,000. And over by the cost. We need to calculate the cost, but fortunately we did it here. So minus divided by this, and you got 0.93. So what this mean? What should we do? We compare X and do nothing option, and then we got 0.93. So is it X should be selected or do nothing? Yes, guys. Hello. Yes, Darwin, are you there? Darwin?
Yes, doctor. Yes, yes.
Yes. So you able to catch the point here? I'm asking after the analysis of X, we got 0.93. So which should be selected based on your opinion?
I'm going to take X.
X should be selected.
Yeah.
Why?
Because the cost is lower than the Y.
Okay. Okay, fine. Thank you, Darwin. So basically, please pay attention here. This cost, we calculate it as a first step for us to order which project or which alternative to be analyzed first. So we are not going to decide based on this cost. Right? So we take this and then we do BC analysis. BC analysis, we compare between X and DN. So X versus DN, do nothing. So from our analysis here, we got 0.93 means that the value is lower than 1. Means that X is unable to win over do nothing. So we are going to basically eliminate X because if it's 1 or more, then we are going to eliminate do nothing, right? Did you get it, Darwin?
Yes, from now I get it, doctor.
Yeah, because X versus do nothing, if it versus do nothing, it should get 1 or more than 1, so it wins. That's the analogy, right? But now it even didn't get 1, right? Yeah. So now
it should
we
greater than 1.
sorry.
I mean the X versus do nothing should be greater than 1, which means it's good now.
If it's greater than 1, then we are going to eliminate do nothing, and then X is going to be there. It's going to be our choice. Now it's do nothing. We eliminate X.
Okay. Okay.
So now we took do nothing. So do nothing is retained. Is retained there. So now we are going to analyze with Y. Okay, with Y. So the same thing. So now we are going to calculate the BC ratio here. The same thing, B over B minus D. So here in this part, okay, so 150, where did we get from? This is the benefit. Minus 45,000, where did we get this from? This benefit. Okay, and then we need to calculate the cost. Fortunately, we did it before, so we just took this information, and then we got 1.07. So what would be our choice now with 1.07?
Why?
Why? Exactly, Darwin. Because it versus do nothing and it's got more than 1. Okay, so we are going to eliminate do nothing, right? Eliminate do nothing, and then we are going to choose Y. So this is going to be the final answer. So based on incremental BC analysis, project Y is selected. So this is the example. Okay. Hopefully you got this. Okay, it's not involving a complicated calculation, but it's just the logic that we need to put it in steps. Okay. Okay. Are you okay? Can we continue, or do you need a break?
Doctor, question.
Yes, please.
Okay, if we use PW or FW, do we need to use LCM?
What LCM?
Yeah, the life cycle, because the different life is 10 years and 20
Yes,
years.
yes, yes. Exactly. We make our effort in trouble. You need to do more calculation. Exactly. Because you need to make it equivalent to the same timeline. Here, because the first is we are going to calculate the equivalent total cost, right? So if you are not using AW, so you need to have another cycle of X. Exactly. Thank you. Thank you for pointing this out. Yes, you are right. So the simple way or the safe way is just to use AW. Okay. So shall we continue or do you need a break?
Continue, Doctor.
Continue. Okay. Thank you. So now we have another alternative given the same scenario, same information, right? If you see here 320, 540, 45, 35, 110, 150, so the same here. But here they have a new condition. You must select one of two alternatives. What does means? What does means here compared to the previous?
Must have to either X, Y, or DN.
Okay. So what we are going to do here? So as Swan said just now, we have, in this case, do nothing is not an option anymore. Okay. So we are not going to have do nothing. Means that this company or this project or whatever it is, they have decided to choose X or Y. So do nothing is not an option, right? So what to do? Similar, we are going to calculate the equivalent cost. Where did we get this from? Guys? Where did we get this from?
AP.
So it's basically the cost, equivalent cost, right? Which is we calculated this in previous example. Okay, so we just took this information. Hopefully you are still with me. Okay. So now you can use the incremental values. So what's the incremental of B? Okay. So it can't run away from BDC. You know, it can't run away from B, D, and C. So you need to identify all of these. So in this case, okay, so we are going to see the incremental value of B. Okay, so 150. Okay, 150 and 110. This is for the benefit. Right? So you got 40,000. So they are comparing Y to X. Okay, and then this benefit is 45,000. This one. So you got 25,000. Okay, and then also the incremental of, so we have B, we have D, now is C. So where we are going to get this C's information, guys? I'm going to
AW costs.
Yes, exactly. Thank you as well. So it's from here. Right? 98 to 97. So you got this value. So now we are going to do the incremental analysis, right? So 40 minus, this is minus, we got here, and then you divide with the total cost. So you got 11.1. What we are going to do? How we can conclude this? Y versus X, you got 11.1. Anis Zulaika, are you there? Anis Zulaika. No. Aniza.
Yeah, Doctor.
Okay, thank you for being there. So I just would like to know your opinion. So we have do the analysis for incremental values for B, D, and C, and then we are comparing Y and X here. Okay, and then the answer is 11.1. So what can we conclude from this analysis?
Can be acceptable.
Which one? Y or X? Confused. Okay, that's fine. That's fine. Anyone want to help? Do we have Haliana Halim?
Yes, Doctor.
Yes. Do you want to help Anis? I'm asking, based on this incremental value, we compare Y to X and we got the analysis value is 11.1. And what can we conclude?
So the Y alternative can be proceed.
Yes, exactly. Thank you, Juliana. Because Y, we are comparing Y with X. So when we are comparing, so the first one, if you got one or more than one, you know, so we are going to choose that. If you got 0.7, means that we are going to eliminate Y because Y lost to the X. But in this case, we are going to eliminate X because Y win over the comparison. So alternative Y is going to be selected. I hope it understand. Did you get it? Who's just now? Anis, right?
Yes, Doctor.
Okay. Okay. So I have a question here, which is the application of what we have went through for BC analysis. Okay. So I wish we can discuss this. I wish you can do and explain, but I just give this as a take-home work for you guys. So try to do this BC analysis for valley side VS, mountain side MS. So you're going to compare. Okay, I give you the answer. It's VS. Right? Can you please check whether you get this answer or not? So so I just skip this for now, but we can come back later if you wish to discuss. But I rather like to give this as a take home work for you. Also, this question 4, you're going to choose these two proposals using this BC analysis. You can just follow the same steps as we discussed just now. Okay. Okay, next is BC analysis of independent projects. Okay. So independent project comparison does not require incremental analysis. Okay, and compare each alternative overall BC with do nothing option. Basically, there is if there is a no budget limit, you know, we are going to accept all the alternative with BC greater or equal to 1. If you have limited budget, you know, it means that we have a capital budgeting problem. So selection follows, they have a different procedure. They have different chapters, but unfortunately, even we are not covering this chapter in our syllabus. If you want, if you like, then we can share. Okay, but what you need to understand here, we also have independent project. We are going to see what are they, but usually you're going to just choose. We do the BC analysis, right? So if we found more than one for multiple project, we choose all. If there is a no budget limit, that's all. Okay. So I believe this is the last method of calculation for today. So hope you can be energetic. We're almost to the end for today's session. So we call this cost effectiveness analysis, right? Service sector project primarily involve intangibles, not physical facilities. Okay, do you agree on this? Like government projects usually is intangible. You can't see whether is it in terms of cost, does it worthwhile, right? Or the return, because it's non monetary based. Example, healthcare, security programs, credit card services. You know, so how we can analyze the effectiveness. So cost effectiveness analysis combines monetary costs. We estimate it with non-monetary benefit. So we include non-monetary criteria here. So basically, we calculate it using cost effectiveness ratio, or CER. So what the information that you need for this? Equivalent total cost and total effectiveness measure. So this is depends on, varies on the methods being used. So basically, it's C over E. Okay, C over E. So this is the procedure. As usual, they're going to explain what are the steps, right? So what you need to do in calculating CER, what is CER just now? Guys? Okay, go back again. So hopefully you can it will save to your mind. Cost effectiveness analysis, CEA, where when we want to calculate this equivalent cost effectiveness ratio to calculate this to when we combine with non-monetary. So we call it cost effectiveness ratio, CER. Okay. So determine the total cost, equivalent total cost. It's very important because we have a different approaches, right? We have present worth, annual worth, and future worth. So it should be equivalent. Then it's an apple-to-apple comparison. So determine the equivalent total cost, C, total effectiveness measure, E, and CER. So once we got the, and then we are going to order the project smallest to largest, CER. Okay, and then we are going to determine the cumulative cost of project and compare to the budget limit, if we have limit. If there is no limit, then we just fund all project. But if you have, then we are going to fund until B is not exceeded. Okay. Okay, this is the example of the question. The effectiveness measure E is the number of graduates from adult training program. So in this case, they have identified effectiveness measure, okay, this effectiveness measure E as graduates from adult training. If the graduates means that effective, the project or the program. For CER shown below. So in this case, CER is given, right? They give you CER. Determine which independent program should be selected. So they ask you, they have 4 programs: program A, program B, program C, and program D. Okay. So you have these 4 programs. And this is the cost effectiveness ratio, the CER per graduate, per graduate. And this is the program cost. And the budget that we have is 500,000. So what we should do first, what they ask you to do, order the project. So we need to determine the total cost. So it's here, it's been given, right? Order the project by smallest to largest, CER. So here we need to do something. So which one should be ranked first?
B.
Okay. D.
B. Bolivia.
Bolivia. Here.
Yep. Smallest CAR.
Okay. So you are right. This one. So this is going to be ranked first. Okay. So this is first, and then this is which one? Number 2, 1, 2, this one, right? And then this 3, this is 4. So we are going to rank B, and then A, then D, and last one is C. So we need to rank the information, okay? As here. So now it's in order. And we also add the cumulative cost, right? Determine the step number 3. Determine cumulative cost of projects and compare to the budget limit. So cumulative, if the cost 98,000, so 98, what's the budget just now? 500, right? Yes or no? Right? 500. This is the budget, right?
Yeah, Doctor.
Okay. Thank you for replying. Okay. So now the cumulative, we have 98, 403, and this one is 768,894,000. Okay. So what do you need to do? We need to select the program until the budget is not exceeded. Okay. So what we are going to select? Can we select project A, program B?
Yes.
Yes, because it's within budget just now, 500,000. And then can we choose all the programs, all the students for program A, sorry.
Yep.
Yeah. Because it's 403. So we choose this. So can we choose D?
No, because exceeded 500K.
Yes, exactly. So definitely we are going to choose program B and A, okay, as the total cost of 403. Okay, so that's the answer. We are going to choose B and A. But on certain occasion, we still can choose some of D, because we still have exceeded value here, 500,000. So how much the money that's left is about 97,000. Is it?
Yeah. Yes, it is. 97,000.
Yeah. So we have 500K. Okay, so if we minus, we have about 97. So we can divide 97,000. You can divide by what's the cost here. This is per graduate, right? So you can, and then if you what you get if you divide 97,000 with this
53 student.
53. So in certain cases, we can also answer 53 students from program D. So we can't take all, which will cost us more than the budget. That's what been explained here. Okay. to expand the entire 500,000, accept as many additional individuals as possible from D at per student rate. Okay, basically our answer is still B and A, but we can choose 53 if this is right from D to expand the entire 500,000. So that's the analysis for this one. Any question? Any question? No? If no, then we just go for the same thing. Okay, for mutually exclusive project. So this is the procedure. It's long procedure. We can explain, but when we we go through the example. If we go through the example, then you're going to have a better understanding. So basically what they say, order alternative smallest to largest by effectiveness measure, okay, and then calculate the CER for first alternative. So this first alternative, we are going to consider it as a defender, okay, and then you are going to compare it to do nothing option. And then calculate the incremental cost, effectiveness, and incremental measure CE for challenger. Okay. Next, higher E measure. If ratio CE challenger is lower than defender, so challenger becomes defender, right? Because it's dominant. So we're going to choose which is dominant. In this case, challenger versus defender. Okay, when the challenger becomes defender. Otherwise, no dominance is present, both alternatives are retained. So we are going to mainly looking for the dominance. How to, if dominance present, you are going to eliminate the defender and compare next alternative as step 3 and 4. If dominance is not present, current challenger became new defender. Okay, next challenger, but all defender remains viable. Continue step 3 to 5. This until one alternative remains, or only non-dominated alternative remain. Apply budget limit or other criteria to determine which of remaining non-dominated alternative can be funded. So let's go to the example. I know this is too long if you want to understand this flow. Okay, so here for mutually exclusive service project. So the effectiveness measure E, what is E? Is wins per person. So they give E is win per person. Okay, yeah. From the cost and effectiveness valuation, so this has been given, which alternative to select? Okay, so what we need to do? So we need to rank based on E, increasing E. So it's going to start with 2, 4, and 7. Basically, if we go back, then this is what has been explained here. Order alternative smaller to largest by effective measure. So this is basically the steps, right? Basically the steps. You can always refer to these procedures. Okay, so it's become like this. Now we have 2, 4, 7 based on this. It's program B, A, and C. So now what we are going to do? We are going to choose this B as a defender because it's the first on the rank. And then we are going to compare with do nothing option. Okay, so we are going to compare with do nothing option. So CE is, this is C, right? This is E. Okay, so this is going to divide it by E. So direct 1400 divided by 2 is 700. Okay. So now what we are going to do? What had happened here? So B over dn, so B is greater than. So this is going to be, so if you check, okay, calculate the incremental, calculate this CR for first alternative and compare to do nothing option. And then you calculate incremental cost, effective incremental for the next higher E, next higher E. Okay. Okay. So now it's A versus B, the next. What's the incremental here? 2,200 minus 1,400. These two. C. And then E is 4 and 2, the difference. So you got 400. Right? So which one? So which one is dominant? A is dominant because it's got a greater value here. So if A is dominant, right, we are going to eliminate the B. Okay, dominant, so we eliminate B. So we are going to do the same. So since B is eliminated, we still have C. Sorry, A. So now C. C is going to be compared with A. We do the same thing. Okay. So now is C and A, C and A. C and A. Okay. So this minus this for C, and then divided by E, this minus this. So you got 1553. Okay. So here, which one is A is no more dominance, right? Because C over A, but C win, right? Something like that. C dominant. So it's no dominance of A, then we retain C. So here we have so we stop until here. But if you want to further the analysis, we can see A also got big value, C also got big value. So we can do different. We can use different criteria or other parameters to further analyze this. But usually we're going to just stop till here. Okay. So this is questions in relation to these steps, which you can try at your own. Okay. So you can always refer to this procedure. Okay, for question 6, I give the answer for you to just double check. You can do this. Okay, 2 questions for each approaches. And finally, let's quickly go on this ethical consideration. Here is normal thing, you know, we are talking about ethical consideration where engineers are routinely involved in 2 areas where ethics may be compromised. One is public policy making, and the second one is public planning. So here is development of strategy, water system management, how to supply or demand of the strategy, blah, blah, blah. And public planning, development of project. Okay, so water operation, distribution, rate, sales, or to outlying areas. This is an example. So here is just what we want to say is we need to maintain the integrity and impartiality and always adhere to the code of ethics. So here is where, especially when we have the right to decide and we can influence something on the project. So basically we have this kind of assessment tools, BC ratios, you know, based on profit. So it should be merely the assessment. It's not other things that may have personal interest. So I believe you understand what we are trying to discuss here, ethical consideration. Okay, so that's all for today. So quick wrap up on what we have we visited VC method used in public project evaluation. So you can use PW, AW, or FW for incremental BC analysis, but be consistent with units. Okay. And for multiple mutually exclusive alternative, we are going to compare 2 at a time and eliminate alternative until it's only 1 remain, as what we did previously, till to the last example just now. So we check until only 1 remains. For independent alternative with no budget limit, compare each against, do nothing, and select all alternative if we don't have a budget limit. This is what we have discussed. And CA analysis for service sector project combine cost and non-monetary values. We saw that example just now. And finally, we have concluded with ethical dilemma, are especially prevalent in public sector projects. So that's all for this chapter. So I hope you guys, I know it's compressed version of the lecture, but hopefully I have tried my best to explain in very direct and also simple way that you can follow. So hopefully, but you need to do the questions that have been given after the example. So hopefully you can have a better understanding of the subject matter. That's all. Thank you very much, guys. If you have any question to ask, anything?
Doctor, the note will be uploaded to Ulearn, right, Doctor?
The notes already been uploaded since early morning.
Good morning.
So you should be able to access that. Please check if it's not visible to you, because I have uploaded early in the morning. So if you are not able to access that, maybe something to do with the